Hello, in this video we're going to talk about modulus. Modulus is a pretty amazing operator, and I'm shocked they don't teach it when kids are really young. Modulus gives the remainder when division is performed. So what do we know? We know that if I asked you to do 7 divided by 3 when you were younger, you would say that that is 2 remainder 1, because you would 3 goes into 7 2 times, which gives me 6, and there's 1 left over. Well, I can actually generate that 1 using modulus. 7 mod 3 is actually going to give me 1, which is the remainder. And that's all modulus does. And so if I do something like x equals 7 mod 3, and we print x, and I run this Python 3, math basics 3.py, there's my 1. That's it. All modulus does, it gives us the remainder when division is performed. And notice that it stores it as an integer. So this is 1 as an integer, not 1.0. So if I took something like 100 mod 5, we know that 100 is divisible by 5, and the remainder then is 0. And so what modulus is really useful for, well, one of many things that it's useful for, is if we say if a mod b is equal to 0, is equivalent to 0, then b is a factor of a, which is pretty great when you're trying to do some mathematics at times. So modulus is great for checking factors. The other thing that I really like modulus for is mod will generate a pattern. Let me show you. I'm going to say a is equal to 0 mod 2, b is equal to 1 mod 2, c is equal to 2 mod 2. And so what I'm doing is I'm modding everything by 2. I don't know why I'm putting spaces here. You don't have to, but it just helps when I'm writing this out. Right now, 3 mod 2, e is equal to 4 mod 2. And what I'm hoping you're seeing here is I have a pattern simply here, going 0, 1, 2, 3, 4, and then I go 5, 6, 7. And I'm modding everything by 2. So now if I print A, print B, print C, and I know someone's going to say, why didn't you use a loop for this? Because students that are doing this at this point probably haven't worked with loops before, but I will work this with a loop in a second. Let's see what we're going to get here. So if I run this now, notice I get, and let's actually add a print in here so you can see it a little clearer. Notice I get 0, 1, 0, 1, 0, 1. There's a pattern appearing. So modulus can be really useful when you're designing, say, a text-based game or a game in general, and you want to figure out whose turn it is. If it's a 2-player game, you keep adding 1 to a counter and modding it by 2. If you get 0, it's player 1. If you get 1, it's player 2. So it turns out that modulus will generate a set of numbers given what you're modding by. So if you mod anything by 2, you're going to get 0 and 1. If you mod anything by 3, you get 0, 1, 2. Mod anything by 4, you get 0, 1, 2, 3. And this becomes really useful when you're trying to pattern things. And that's all modulus is. Modulus is simply an operation that gives the remainder when division is performed. Now, the last thing I want to mention is that with modulus, you have the same restrictions that you have with division. And that is, you can't mod by 0. And the reason you can't mod by 0 is because in order to calculate the mod of you have to perform division. So if you had 100 mod 0, you'd have to calculate 100 divided by 0, which doesn't make sense because we can't divide things by 0. Likewise, if I put 0 mod 100, this is one that often gives students pause. If I take 0 mod anything, the result is always 0. Oh, let's try that again. What line? Line 10. That is not what I have at line 10. So let's just write this again. Let's clear this and let's try this again. There it is. Sometimes replit can be a little finicky. So in this case, 0 mod 100 is 0 because it's like we would have to perform 0 divided by 100. And if we divide anything by 0, we get 0, remainder 0. Keep this modulus in mind. It's a wonderful operator, and it's really useful in a lot of different situations. If you have any questions, please don't hesitate to reach out. Have a great day.